Hello, welcome to my easy statistics. In this video, I am going to discuss about chi-square goodness of fit test. We know chi-square is a non-parametric test where we have dependent and independent. Both will be nominal or categorical variables. But in this case, we are going to take only one variable, which is a nominal variable. And we are going to discuss this chi-square goodness of fit test with the help of a case study. Here we are going to analyze BMI, body mass index classification distribution. Background is a health research team is investigating the distribution of body mass index classification among a sample of individuals. The body mass index classification are categorized as normal weight, overweight and obese. The team aims to determine whether the observed distribution of BMI classification matches the expected proportional based on prior information. The hypotheses are null hypothesis. The observed distribution of BMI classification, that is normal weight, overweight and obese, matches the expected proportion of 0.28, 0.32 and 0.40 respectively. Now in the data we have already observed variables are there and there is a expected proportion, means normal weight is 28% of the population are normal weight, 32% are overweight and 40% people are obese. So this is called expected. Now we are going to see that whether there is any difference between observed distribution to the expected distribution. Alternative hypothesis, the observed distribution of BMI classification does not match the expected proportion. Data collection. The research team collected data from a sample of 183 individuals. The observed distribution of BMI classification in sample is as follows. So 93 people are normal weight, overweight is 62 people and obese are 27. Expected proportion already we discussed. Normal weight are 28%, that is 0.28. Overweight 32% and obese is 40%. If we add all this, they must be equal to 1. Now what we will do, I will show the example now and we will do this chi-square goodness of fit test and we will discuss the results. This is the example of a BMI. So this is the data of a BMI. I'll show the variable view. In variable view, we have three nominal levels: normal weight, overweight and obese. Okay, you can see the data is normal. Now we will do this chi-square classification, goodness of classification. Let us start the analysis. Analyze in this non-parametric test. In non-parametric test, we must select legacy dialog. In legacy dialog, chi-square. Once you select chi-square, now we got this pop-up window where we need to take this BIM from left side to right side. Now this is the test variable. Now we need to mention to system what is the expected values. The expected values are, we have a proportion. The normal weight is 0.28, add it, and next the overweight is 0.32, click add, and the obese is 0.40, add it. Now this is in the sequential form. We have given 1 for normal weight, 2 for overweight and 3 for obese. So same sequence you must also mention what is the expected values. Now after doing this, simply click OK. Now this is the output window where you can see the frequencies. This is the BM value, observed values and expected number. There is a difference between observed and expected. If you see the test statistics, you will be seeing the asymptotic significant value 0.000. We already have mention the null hypothesis. Null hypothesis says there is no significant difference between observed and expected BIM index. But if the significant p value is less than 0.05, it means we are rejecting the null hypothesis and coming to the conclusion that there is a significant difference between both observed and expected values. Now if you see, this chi-square value goodness of test is conducted to compare the observed distribution of BIM classification. Chi-square value we got 57.228, degree of freedom is 2, the asymptotic significant value is 0.00. Now interpretation, based on the p-value being significantly smaller than the typical significant value of 0.05, the null hypothesis is rejected. This implies that the observed distribution of BMI classification does not match the expected proportion as provided. The chi-square goodness of fit suggests a significant difference between observed and expected distribution. Conclusion, the analysis reveals that the observed distribution of BIM classification among the sample significant deviates from the expected proportion. This finding indicates that the distribution of BMI classification within the sample does not align with the historical data or prior expectation. So this is the analysis where we are trying to use this chi-square goodness of fit method to see whether there is any deviation between observed to the expected value. I hope this video is useful for your research. Thank you.